calculus, we're in the middle. Okay, here we go. So our answer is something like 3 natural log of the absolute value of x plus 2 minus 3 natural log of the absolute value of x plus 3. Say, as often happens in the back of the book, you saw a little different answer. What single term might you see as a consequence if you use log rules? X plus 2 over x plus 3, that whole quantity to the third. I don't require that you simplify like that, but as always, I want you to know if you did it right or not. So you need to be able to see that. All right? Questions? All right, try this guy on your own, and let's try that first one, see how that goes. You could do that by completing the square and inverse trig, but today you're going to do that by partial fraction composition. Next homework will give you both ways. Okay, now in terms of comparing your work to a student next to you, it depends a little bit on what order you have the sum in. If you wrote x plus 4 first, and the other person wrote x minus 2 first, you're both going to be fine, but you need to understand what A is and what B is for your problem. For me, A represents the numerator that's attached to x plus 4. And so one of my decomposition should be that I have a 2 over x plus 4 and a 1 over x minus 2. Do you agree with that decomposition? Okay, the order doesn't matter. Just make sure you attach the right numerator with the right factor denominator. After that, you're integrating. And you're integrating. And so maybe 2 natural log of the absolute value of x plus 4 plus the natural log of the absolute value of x minus 2 plus c or some equivalent form thereof. Do you agree? Okay. Now, set 115 is actually huge. I mean, it's gigantic. In fact, set 115, you'll see we're going to do over 3 days. This is a skill you need in 115, but the real star of the show is logistic growth. And this is the differential equation for logistic growth. It's the second most famous differential equation there is. Tomorrow we'll talk about what the heck it is, but today what I want you to be able to execute is the antiderivative of that. You can see it's a partial fraction decomposition. So use partial fraction decomposition to integrate that. Understand that P is the variable, L is just a constant.
So the D.
Zero and L. That's
TP you can blow off until you're ready to integrate. Let's call it a 1 in the numerator.
Yeah, or like taking a text. So, if all people want to oh my gosh, I'm so I was like, if all people want over L, right?
Don't worry about the DP first, just call it 1. So what did you let or P equal, rather? 0 is good, because then 1 equals AL, and L is, or A is? 1 over L. What else?
Wait. Back it up.
What did we do first? Sorry, did I make a mistake? Let P equal, or L.
It's 1 over P.
A is over P, not L.
Oh, gotcha. Gotcha. Sorry, now I'm with you. I apologize. Here we go. So, 1 equals A times L minus P. Thank you, you're right. Okay, now you say let LP equal L. If P equals L, then 1 equals BL, so B is 1 over L. If we let P equal 0, then 1 equals AL, so A is 1 over L. So the problem starts to take on a flavor of 1 over L over P dP plus 1 over L minus P dP. Or 1 over L is a constant. So, be careful you're not out of the woods yet. This one's easy, 1 over L, natural log of the absolute value of P. In a real life problem, there would be no absolute value because it's positives only, but we'll go with it. Plus, well, we'll see here. 1 over L. Be careful, be careful. You have a function within a function, so you have to at least mentally consider the ramifications and use of. What's U? L minus P. What's du? Negative dl. This is negative or minus 1 over L. Natural log of the absolute value of L minus P. You must have a negative. Plus C. If you stop there, I'm fine.
Wait. Why?
This is because if U is L minus P, then du is negative D.
Oh.
It's terrible.
Okay? Okay. Is that okay? Cool. All right. Last but not least, did I make a mistake? Oh, okay. If you get a factor in the denominator, but the power in the numerator is greater, it's improper because x cubed is greater than x squared. In such case, you must first divide. You must divide. And then you will partial fraction decomposition on the remainder. So, here we go. Do you remember how to divide polynomials? All right then. X squared plus x minus 12 divides into, don't forget your placeholders, x cubed plus no x squared plus 3x minus 2. You look at the first into the first. How many times does x squared go into x cubed? X times. You multiply and record it below. X cubed plus x squared minus 12x. Typically then in long division, we then subtract that quantity. So we'll change signs, draw the line. You should gradually be working right in the problem. X cubed minus x cubed goes away. Negative x squared plus 15x, bring down the next term, minus 2. Then you do it again. X squared goes into negative x squared. Negative 1 time. Negative x squared minus x plus 12. We're subtracting that, so change signs. Draw the line. 16x minus 14 is your remainder. It goes over the divisor. So far, so good. Okay, now we're ready to decompose the remainder. We are to break 16x minus 14 over x plus 3 plus 4x minus 3 into a over x plus 4 plus b over x minus 3. Let's see where I'll pull it from, my old friend. Okay, so I get 16x minus 14 equals a times the quantity. X minus 3 plus b times the quantity, x plus 4. We choose our x as well to help us. Let x equal 3. If x is 3, then what's 16 times 3? Minus 14. 34 equals a goes away, b times 7. Therefore, b is 34 over 7. That's more like the ugliness I was expecting. Let x equal negative 4. What's 16 times negative 4? Negative 64 minus 14 is negative 78 equals a times negative 7. B drops out. A is 78/7 positive. Now we're ready to integrate. The original problem is equivalent to what? The antiderivative of the integral of x minus 1. Don't forget that original divisor, or quotient rather, excuse me. X minus 1 and 34 over 7 goes with what fractional factor? It goes with x minus 3 and 78/7 goes with x plus 4, whatever order. Just all I ask, obviously, is that you know which numerator goes with which denominator properly. I don't care what the order is. So, our antiderivative, finally, run it in for the touchdown. 1/2 x squared minus x plus 34/7 natural log of the absolute value of x minus 3 plus 78/7 natural log of the absolute value of x plus 4 plus boom. Isn't that easy?
Yeah.
All right. So you can see that there's actually, I wish I'd give you more, there's only one of those where you have to divide. But your homework tonight is just partial fractions plus a little extra.
Yes. Where does the x minus 1 go?
The x minus 4,
No, the x minus 1.
it comes from the quotient.
Oh, okay. So it's
Yeah, that I just brought down after, brought back. Okay. Okay, questions on 114. You should, let's check the replacement answer. Sorry, give me 1 minute. Okay, so for number 4,
What a great gag.
Did you get the circle x squared plus y squared equals 16 for the eliminated parameter?
Yes.
For the domain restrictions, did you get that x is between -2 and 4?
Yes.
And that y is between 0 and 4? I don't think so. I could be wrong. For these, I know that theta is from 0 to 2 pi over 3, and therefore x goes from a max of 4 to a min of -2. So that's where I got that. As x goes this way, it's starting to decrease. And by the way, my movement doesn't have direction. It should go that way, counterclockwise. Okay? Y starts at 0, goes up to 4, but then decreases a little, range is 0 to 4. Very cool. Yes? Good question. You could do it one of two ways. You could find successive points like the starting point at time 0 and the ending point and just say, where did I go from and to? Or you could use calculus. I think you'll agree that this is the position at time 0. If you looked at dy d theta, it is 4 cosine of theta. Now, if you look at that at theta equals 0, this then means that at the starting point, y is changing in a positive way. And so I know from that point, y increased. That's also going to tell me it goes up that way. Okay, so to say that again, you can either use a point and a point later, or you could use calculus to find a point and how is it moving at that point by derivative. Does that make sense? Okay, we'll practice that a little more too, because I need to hit on that a little. All right. If you're like me, I don't remember things very well, so I don't remember formulas very well unless I understand the concept behind them. So when I go to find the length of this geometrically, I just say, well, I don't know the formula, but I do know that it's a fraction in the circumference, right? In terms of what fraction, it looks like it's a third, which would make sense. 2 pi over 3 out of 2 pi is 1/3. So it's 1/3 of pi d, so 8 pi over 3 units. Cool? Okay. The next replacement is that big one to the lower part. First of all, I hope that you figured out over the course of the problem this was calculator active, because you needed a calculator. Sorry. There were a couple calculator skills in here you needed to get. First of all, can you put your calculator in parametric mode and graph it and see what you get? If you do that well, it should look like a path of that. It goes positive for a little while, then negative between 0 and 1, and then it goes back to positive between 5 and 6, I believe. And the direction is, as you see. Okay? How'd that go? Good, good. B, at what time does y attain its minimum value? Now, I think if you try and go to in parametric mode, try and ask the calculator to find that point, it's going to say no dots. If I recall. I know for 84 for sure that's a no-go. Okay, the calculator doesn't find minimum points on parametric graphs. At least it didn't. I don't know if they've updated it. So the workaround is this. You go to function mode and you just graph the y equation. Just put it back in function mode. Graph y equals x cosine of f. Set the window to 0 to 2 pi and look for the minimum y. The minimum is at time equal 3.4256, I think. And then the position at that point, you go back to parametric mode. Actually, you probably store that. You're going to need that. Go back to parametric mode. Your equations will still be there. They don't get canceled out. They're still there. You just find position at that time, horizontally and vertically. I don't have those there. Yes?
Could you do?
You could of the y of this, you mean?
Yeah.
Yes, you could.
Yeah, but that's got pi. Instead of, well,
I could be wrong, but I don't,
put that into
Oh, that's
this.
what,
so.
no, I did first with how I got this maybe answer.
You got this one?
Yeah.
Okay. All right, so just check your work. It sounds like critical, endpoints are critical, points are fine. That sounds good. I had for the equation for the tangent line, did you get pi negative pi for the point? I hope that's a yes. I have negative 1/2 for the slope. And, sorry, I didn't show my y derivative. My y derivative was something like cosine t minus t sine t at pi. Slope is negative 1/2, so here's my tangent. Check. And last but not least, parametric arc length is the Pythagorean theorem idea. You're adding the squares of x squared and y squared. That's what we did Friday. It's 16.452-ish. Can I get a yes? No? Okay. Cool. For D, it's something like an arc length of 16 or a distance of 16.452. Remember, in parametric, arc length equals the distance because the arc is the path that the thing is traveling upon. Okay? I'll be happy to go back over those in more detail. This one is C. This is the one right below it. It does clean up a lot. Sure.
Wait, can you go back like just put 0? Yeah, that's.
That one?
Thanks, yeah.
Sure.
Wait, no.
Good? Okay, this one? Should anybody else want to shoot? Is this worth going over right now while it's here? Or?
Yeah.
You sissies, this is fine. It doesn't, you don't even know what you're doing? It's this idea, first of all. Do you agree? Right? Do you agree?
Yeah.
Okay. So now the question is, can you take the derivatives? What is your x prime? Leave A, did you distribute the A or leave it up front?
Leave it.
Leave it, A, okay. What's the derivative of cosine t?
Minus.
Minus sine t. Beautiful. What's the derivative of t sine t?
Did you pull A all the way out?
I suppose you could. Did you pull A? Well, I'll do it in a second. What's the derivative of t sine t? Sine of t plus. Hello? Plus t cosine of t. All squared. You can see why that will be delightful because there's a negative sign and a sign that go away. Okay? Now, y prime. A. Derivative of sine is cosine. What's the derivative of negative t cosine t? Let's start with the derivative of the cosine, or the t is just 1, so that's negative cosine t. And then minus, or plus, t sine t, all squared. We wait? Wait. Okay, so that amounts to 0 to pi of a cosine, a squared cosine squared plus a squared sine squared. We?
Here's the 2 squared. Wait, is the A squared?
Oh, there's a t. Guy. Okay, let me go slower here. A is not squared. What the heck?
A squared, T squared.
A is squared? Yes, it is squared. A squared,
T squared.
t squared, cosine squared. Boom. Plus a squared, t squared, sine squared. If we factor out a squared, t squared, we're left with sine squared plus cosine squared. So how does that all clean up? A t dt. So what is the antiderivative of a t with respect to t? half a t squared from 0 to pi, so a over 2 pi squared minus 0, that is, wait, boom. Okay, first thing I want to mention on the polar graph at number 14 is, I pulled a bit of a switch on you, and I just assumed in your brilliance you would be observant enough to see it, and many of you did not. So the original graph I gave you in notes was graphs with the reference angles only. Like that, yeah? I don't know if you remember that, but that's why I gave you in notes. That's not what you're given here. Okay, this has these also, basically every pi over 12 or every 15 degrees. So please be aware of that. And when you say my first petal is at 0 degrees because it's cosine, and I know the 3 petals are evenly spaced at 120 and 240, locate them correctly. This should be 2 spokes left of the 90-degree mark, not 1. And this should be 2. That's where 120 and 240 are. Be careful. Mostly, just look at your graph that you're done. Are they evenly spaced or not? If they're not, you did it wrong. Okay? All right. Your area is 0.785 for your rotation. That's unfortunate. Okay. So you're 131. Yeah, I have no idea how you got that. Okay. Wouldn't you say that we use a half a pedal typically? Yes. Okay, so we're starting at a tip at 0 and going until r equals 0, which is where the pedal ends. R equals 0 is cosine 3 theta equals 0. At what angle is 3 theta? Or is cosine equal to 0? Pi over 2, so that means theta has to be pi over 6. Now, that's a half of a pedal. How many half pedals are there? So 6 times a half of r squared d theta. The formula itself is always 1/2 r squared d theta. Always. It's always 1/2 r squared d theta. And so it looks like that. All right. Are we good? Okay. I guess that's it for replacements. Other questions?
I'm still getting, I just put it in my also twice what you have.
Oh, so I was going based on what fifth period told me. I didn't.
That's fine. I got 0.75.
That's
It is correct or isn't?
I got it.
Is it in radians, first of all? 3 math 0, 2, 5 divided by 6.
No, you multiply by 3. You get the 6 divided by 2. No, this is you're right. Yeah, you forgot to count that 2.
Oh, okay. I'm getting 0.7853 now. Okay, we're good? Okay. Questions on 114 besides those? 29? 1.
Wait, yeah, and 22.
22?
Not 20.
15?
Oh, never mind.
Oh, not 22?
No, that's here.
Okay. Okay. 20, I assume that's still a question. 114,
Yeah.
20.
Yes.
Okay.
Wait, I can tell you exactly where I'm stuck though.
Okay, heavy.
I have the right, or I don't have the answer. I have like divided by 2.
Oh, okay, yeah, actually. Can I have your answer and the
Yeah, that's
answer
what I.
key?
Yeah, I don't know.
So you got what correct. All right, so I have a lot of people that say this. In fact, most of you probably say this. And the question is, how can that possibly equal this? How can we make that coincide? Let's look at the left-hand side. There's more to do. Factor out a half. Natural log of a half. What do you think then?
You can separate it to natural log of half plus natural log. The natural log of half plus factor of C.
Yeah. So your answers are the same, but your C's are different. They are rolling natural log of a half into their C
So,
to get a different C.
That's the dumbest thing.
yeah.
Really? Ever?
I mean,
Why would
that's
you
definitely
think
out
about
there.
That's the dumbest thing you've ever heard?
That's definitely top 40.
I think
You should be a teacher.
I think it's dumb, but it's unnecessary. But it's unnecessary.
I had a kid who said he wished he had diabetes.
Why?
It was right before lunch, and this kid had diabetes, so he had to keep eating. And this other kid next to him was hungry. He goes, "How come you can eat, but I can't eat?" And the kid said, "I have diabetes." And the kid said, "I have how about 9? Question on 9. So the hardest part I probably have trouble with is what's the equation? Newton's method finds zeros. So when they ask, okay, so you have to make it a single function that involves a zero. So how can I make this find a zero problem? Yeah, you want to set them equal to each other and then go one better and say this really needs to be. Oh, okay, then you got a good start. Then let's continue. So let's line up with x equal x squared minus sine of x. Obviously, up 9 then is 2x equals 4. Okay, so I think I said initial value of 1. I gave you that. Maybe. Check your formula. Did you do x initial minus or plus?
Yeah, I did minus.
Minus and f over.
For F prime, right?
Okay, that's right.
I believe that's.
It's possible you put it into your calculator.
Okay.
That's one iteration. In 2 iterations, it's 2x2. Okay, so let me know if it doesn't come out. All right.
What did you get iterations?
What's that?
What did you get for the iterations?
I didn't do it. I don't know. I assume you're also hoping not to. Yeah. Gotcha. Want to check that?
I just want to make sure I'm correct.
You should. You and me. We should. Between 2 of us, we really should just split the work up. You
We would get
Number 1. Question on 1.
Yes.
All right.
I know.
Yeah, this is cool. Okay. So, they say that this is a pool where your cross sections start out here.
Yeah.
Oh.
Yeah, what?
You
Bananas?
You're making smaller and smaller cross sections and so on. So it's kind of roundy bottom thing. Wish I would have drawn that better. I feel like I could do better. You get this. All right. So look at a single cross section. What's the thickness, dx or dy? dy. What's the width? Just in terms of x's. How wide is each of those? 2x. Okay, because they're squares, that also would be 2x. So can we agree with the sum of 4x squared py's, which obviously won't stand, as our starting point? Sorry, I didn't draw it very well. It's still, the cross sections are going down. It's a pool, so most of the depth's there. Maybe I should have just drawn it reflected off on it. Because it's y, then we need to replace x squared with its y equivalent. X squared is 1 minus y squared over 100 multiplied by 25, or 25 minus y squared over 4. Wait. So if I take, actually I'm going to leave that 4 in, I think. See that? If I take that 4 and multiply it by 25 minus y squared over 4, then the integrand becomes 100 minus y squared. From where to where, considering it's y? Negative 10 to 2.
Could you do 0 to 10?
You could, there is symmetry, so you could go 0 to 10 double. Okay, are we cool with 1? Huzzah. 22. Is 22 still a question?
It is.
Okay.
Wow. I'm just blessed.
That's a lot of learning going on there.
It is.
0 to 1. Okay, what trig substitution did you make? I agree. X is maybe root 6 tangent theta? Tangent u, tangent theta, whatever. Okay, so that would become then 6 tangent squared plus 6, which is root 6, tangent squared plus 1 is secant squared. That seems like that's working just fine, yeah? All right, so now let's change everything else. dx, if x is root 6 tangent theta, then dx is root 6 secant squared theta.
Yeah.
Okay, so the denominator, the numerator becomes secant root 6 secant squared theta d theta. And the limits of integration. If x is 0, then theta must be 0. If x is 1, then theta is the inverse tangent of 1 over root 6.
Yeah.
I stopped there.
That scares me. We'll see how that pans out. We might clean it up. All right. This then is the antiderivative of secant. This is a humdinger. The natural log of secant plus tangent. We win.
Wait, could you just simple it and just like put it regular, but once you convert it back into a tangent, or into exponent, and then plug in the numbers?
So you say do an indefinite integral and then bring back?
Yeah.
Did you prefer to do that?
Yeah.
Okay. I am down with that. So we're not going to do that. We're going to take the antiderivative and we'll deal with the limits in X later. All right, so Actually, the C is not going to be an issue because it is definite integral. All right, so back here, I know that x over root 6 equals tangent theta. Wait. So theta is an angle, opposite is x, adjacent is root 6, making this the square root of x squared plus 6. So secant theta is adjacent to hypotenuse flipped, so hypotenuse to adjacent, root x squared plus 6 over root 6. Tangent is x over root 6. Cool? Okay then, so then, this is equivalent to natural log of x squared plus 6 plus x all over root 6 evaluated from 0 to 1. Yes? So that's natural log of the absolute value of the square root of 7 plus 1 over the square root of 6 minus the natural log of square root of 6 over 6.
So you changed it, you changed the bounds, but.
I did not change the bounds. After talking, I thought it was good advice. Ellen, I think, said, let's not go definite integral. Let's just go, what's the antiderivative?
Yeah.
Find it, and then evaluate it. Yeah. Now, it's important that you never write a definite integral with theta with the old limits. Otherwise, that's
Okay,
bad.
yeah, because I knew that was a problem, but then,
Yeah, never, you can do the antiderivative off to the side, or just generally speaking, and then evaluate. This goes to 0, and so, I guess that, or some equivalent formula.
when you like take off the bounds.
I made it an indefinite integral to find the antiderivative, and then, once I know the antiderivative, then evaluate it.
Wow.
Okay? All right, other questions on sets 114?
Can we go over 25?
25. Yeah, that's a bit of a funky one. Y equals, I'm going to call that y1 equals cx minus x squared. And y2 equals x squared plus ax plus b. They are tangent to each other at 1, 0. Give me one thing you can do with that 1, 0.
Plug it in.
Plug it in, yeah. If you plug it in, then you know that 0 equals c minus 1, which implies c is 1. And 0 equals 1 plus a plus b, which doesn't really do much for you. I guess that means a plus b is negative 1, yeah? All right, well, surely then we need to do something else to get a and b. What is another idea? Yeah, the derivatives. What do you know if two curves were running different? What would you know about the derivatives at that instant? Yeah, the derivatives at that point are the same. So y1 prime equals y2 prime at x equals 1.
Tutoring help last semester. Please check
So,
in with your 7th hour
something like
teacher first.
c minus 2x equals 2x plus a at x equals 1.
Please check
So
in with
c
your
minus 2 equals 2 plus a. Well, you don't see, sorry. So that implies that a is negative 3, and therefore b is 2.
Oh, yeah, I forgot about that.
I get how we've done it, but for I see how Brian got it too, but I don't really understand why mine didn't work. Okay, so I found like and then I took PhD over to but what Ryan did was like
You will get it done. Hey, you can just make it my birthday.
So I was trying to figure out what K equals 0.
February 17th. So just wait like a month and
Or cosine. Or sine equals 0, because that's also a sheet.
I just don't see, I can think of a way off the top of my head. how that can be. So you have
I remember doing it, but I don't remember.
cosine t plus sine t plus t sine t. So if you get
I don't have everything written down and she's making this other day. So I was like, that's not wrong. It just was just addition stuff. That's pretty much.
Thank you, Mr. Richmond.
You're welcome, have a good day.
So
So
then,
it's cotangent of t plus t equals 0. So let's see. Maybe you looped it over and divided it back, but that would be the 1 on that side.
oh, yeah, that might be it. Got to, yeah.
Cool, you bet. Hello, sir.
Yeah,
Just having trouble figuring out how I should show my workload.
Which one?
It's like whether it merges or not merges with.
This one?
Yeah. So, I should just leave.
Yeah, this, you're right, I see what you're saying. As it gets infinitely big, pick embiggator instead. As it gets infinitely big. Think of a trillion and 4 over a trillion. That 4 doesn't mean jack, that's what it's just. Exactly, so I think that's, boil it down to 2 terms. If you get something like this, rather than think of them separately, think what does that all together come to? Now, I could do L'Hopital on that, and it'd be 1 over 1, and that would be there also. But mostly it's 1. Okay?
Can I do?
Oh,
trying to
come here tomorrow.
all that.
Yeah, geez, we went through 100,000 questions today.
I know.
But you need
I know.
100,000 too.
Yeah.
All right, yes, let me stop this recording. Bye.